Hello, how's it going? So this is part 3 of machine learning versus NHL 94, Devlog. So just a quick recap. In part 1, we saw that for sports games, this is quite a challenge because the rewards are quite rare. Rewards is a goal in this case. So it's hard for the AI to figure out what are the steps needed to get to this goal. So we decided to divide the reward function into multiple sub-goals. So if you watch a video, probably already know that the game provides many useful stats like face-off won, successful passing, shots. Lots of variables that are useful to get to a goal. That if you reward properly, it will make the AI learn the subsets necessary to get to a goal. So we tried that, but the problem is that it's still not enough for the AI to learn. At least after a couple of million steps. It gets better for defense, but for offense, it's clearly not enough. So obviously, the next step was to try on simpler scenarios, like for shootout. But the problem with shootout is that it's easy for the AI to exploit the game's loopholes, like pass through the goalie. So in the meantime, someone pointed to me that there was a one-on-one ROM hack. So if you watch the OpenAI integration tool video, you probably already know, but we'll assume that you didn't watch it. So there's a one-on-one ROM hack where it's just one, like you see on the screen right now. That is very convenient for us because it's enough to be a huge challenge, and but not too simple so that the AI can find loopholes and win the match this way. Before we start, I want to point out that about 3 weeks ago, some people invited me to the NHL 94 Discord, and they were kind enough to create an NHL 94 AI subgroup, and there's already many comments, as you can see, and it's quite useful information and also hints about NHL 94 that I did not know. And one of those comments is about what the AI sees. Like there was a concern of, can it see the puck when we downsample to 84 by 84 in grayscale? And that's a very valid concern. So for that, I did to the interface what the AI sees. 84 by 84 pixels. I upscale it a bit to make it clearer. There's the last 4 frames. I just displayed the last frame because there's not enough space. So you can see that it sees the puck. Is it distinctive enough? I would guess so. But I will make some tests with bigger inputs when I have time. So there was already the confidence level of each output that was already there. But what I did also is the game stats. So player 1 and player 2 shots, passes, body checks, and face-off won. I plan to add more stats later on. And speaking of features, I also added a new one where you can play against the model, actually. So I'm going to quit this. So because, as you know, one of the end goals of this project is to make a better AI for NHL 94 so we can play against more interesting AI. So back in the Genesis days, they had very limited resource to work with, limited hardware resources. So the AI was quite good, I think, for the time, quite interesting. But obviously there's room for improvement. And the other goal is to make some AI versus AI competition. The other reason is to be able to debug the limitations of the AI. So it's very useful to stress test our AI that we train. So we'll get back to this later. This week I trained a model for 80 million time steps. So 80 million time steps, if you want to know, is about 61 days of human time. So that's quite a lot. So here's the result. you can see it starts the game quite well with a good shot, quality shot. But as you will see, the rest is still very poor. Plays poorly. Like it doesn't chase the puck at all. Like it stays in the offensive zone. The goalie has trouble passing to its player. And even on defense is not quite good. It learns to do sometimes some body checks. And when it does and it gets the pucks, like as you see, well, actually this was not a body check because as you can see in the stats, it doesn't count as a body check. But when it gets the puck, it, like you can see, it often dumps the puck down. And one of the reasons I think is because since I punish the AI for when the opponent takes a successful shot to the goalie, I punish the AI. Probably it found out that when it has the puck, in order to not get punished, it should dump the puck instead of trying to keep it and reach the offensive zone, because probably when it tried to do that was not skillful enough, and the NHL 94 AI managed to take the puck back and do some successful shot and get punished. So I think that's the main reason. So I will show you the script, word function script I use. It's quite similar to what I showed in the OpenAI integration tool part 3. But I'll go back on it. So basically, it rewards for scores, obviously, face-off 1, which is getting good at, body checks. Sometimes it makes some body checks. And I punished for shots. And I punished for scores, obviously. And for shots, I make sure that it's not before the offensive zone. So 150 is quite far into the offensive zone. So this ensures it's quality shots. In the comments on Discord, I remember saying also adjusting for the X value. I didn't do that yet, but I will do. So make sure it's not from a too steep angle. And I tried many things, not to train this model, but before I tried the previous weeks, what I tried is, for example, giving reward to chase the puck. So I calculate the distance between, as you see, between the player and the puck. And if the distance is smaller, it gives a smaller reward. And if it's this distance gets bigger, it punishes the AI. But the problem is that it didn't work well with the other rewards and didn't give good results. Also, giving time to giving rewards for the puck being in the offensive in the certain zones, it encouraged the AI to dump the puck. That's the problem. So a lot of these solutions encourage the AI to dump the puck, which is quite annoying. So I need to find a better reward for that. There was in the comments. There's lots of ideas. I just didn't have time to the comments on the Discord. There's lots of good ideas. I just didn't have time to implement it yet. I will try those, but I feel that it won't be enough to get proper AI. Probably will work, but not enough to get an interesting AI. So as I already discussed in previous videos, is that I think the real deal is also imitation learning. So have a bunch of expert player play and give examples to AI and learn from this in order to kickstart the training. And this is what the modern robotic companies do actually. They kickstart the training by giving the robot useful examples. Robots for factories, for picking objects in factories, for example. So I plan to do that, but this takes quite some time. I don't think I will do this month. So this month I plan to take more time to do better reward function and see how far we can go with this. The other solution I was thinking today is about doing a mix of classic AI and machine learning. So basically doing manual pathfinding and manually getting towards the puck, but using machine learning for recognizing situation instead of for everything like we do right now. So that might be a good step. There's lots of solution out there that doesn't use machine learning for everything. They separate into classic AI and just apply machine learning to the right parts. So this is one of the next steps I'll investigate. And if you want to see how dumb the AI is, even after 61 days of training, that's why I made the player versus model, as I said before, like for debugging. It's gonna start soon. Okay, so I'm playing as the Senators, and the AI machine learning is the model is the Penguins. So you see, it doesn't even chase the player, doesn't even chase the puck. Didn't learn that. So even if there's a reward for body checks, tries to body checks, but didn't make the relationship between body checking the player versus body checking the ramp or something like that, or the air. So it's very poor. But when I come close, sometimes it managed to figure out. Not in this case, obviously. So it's very... so if we... like, as soon as you have the puck, it dumps the puck. So it didn't generalize properly. So for face-off, it's getting good. As you see earlier in the video, when it face off in the center, it learns to feint the defense and have a quality shot. But even for as soon as it's not in the center, it doesn't make the relationship between being at the center and being other place, which is probably should be the same behavior, but it didn't make that link yet, even after 61 days. It's quite terrible. But anyway, like being able to play against the model is quite useful. I plan to make this available, the code available later this month. At the end of the month, I need to fix some problems on Windows because I know most people will want to try this on Windows. So I need to fix that first. And I will do a dedicated GitHub project for this. Right now I have one, but it's in private still. So I'll make this GitHub project public. So a dedicated GitHub project public for this. And so yeah, so the next step, as I said, I will build a better reward function, less messy, and probably train for a longer time, because that's one of the issues. One of the mistakes probably I made is that I trained for too short periods of time. So a lot of the sub reward function I tried for around 10 million time steps, which is not enough. Even 80 million, as you can see, is not enough. And as OpenAI said in one of their blog posts about Dota, if I remember correctly, for long-term rewards, sometimes the solution is not some fancy word functions. Sometimes the solution is to let it run for a long time and see how it goes. But I guess that depends on the game and depends a lot of factors. But I will try to give it more training time to see how it goes. So that's it for this video. I hope you like it. If you want more details, you can ask me in the comments. Hopefully I'll make another one in 2 weeks. I'm quite busy with my main project, but I'll try to make one in 2 weeks. Thanks for watching. Please don't forget to subscribe and press the like button. See you.